Based on what you were describing, this could soon be the biggest story in the world. Literally the biggest story in the universe.
Right now, at this very moment, Earth's planetary defense system has been activated. Not for a drill, not for a hypothetical scenario, for a real object currently racing through our solar system. November 27, 2025, just 2 days ago, the United Nations formally initiated Protocol 8 of the International Asteroid Warning Network, deploying observatories across the entire planet to track, measure, and analyze an interstellar visitor that some scientists believe might not be what it appears. This isn't a movie. This isn't science fiction. This is happening right now, and the trajectory they just confirmed is raising questions that even NASA can't fully answer. Think about what that means. We have a global planetary defense network established by the United Nations specifically to protect Earth from cosmic threats, and they've just activated it for only the 8th time in history. But here's where things get absolutely extraordinary. The object they're tracking, called 3I Atlas, has displayed behavior so unusual, so statistically improbable, that the cumulative odds of all these anomalies occurring naturally calculate to less than 1 in 10 quadrillion. Before we dive into why this protocol activation is unprecedented, and what it reveals about the trajectory that's been confirmed, make sure you hit that subscribe button and turn on notifications, because this is a developing situation with updates coming almost daily. And if you want to be part of the community following this historic moment, smash that like button right now. The International Asteroid Warning Network isn't something most people have heard of, but it's been operating since 2014, established following formal recommendations by the United Nations Committee on the Peaceful Uses of Outer Space. IAWN functions as Earth's early warning system for near-Earth objects that could potentially threaten our planet. It's a collaboration of organizations and astronomers worldwide who work together to detect, monitor, and characterize potentially hazardous asteroids and comets. Since 2017, IAWN has conducted observing exercises roughly once per year to test capabilities, refine techniques, and ensure that if a genuine threat ever emerged, the global community would be ready to respond. These aren't casual observations. These are coordinated campaigns involving dozens of observatories simultaneously tracking the same target, testing communication protocols, verifying measurement accuracy, and exercising the entire planetary defense infrastructure. On October 21, 2025, IAWN made an announcement that sent ripples through the astronomical community. They declared that their 8th observing exercise would target 3I Atlas, making it the first interstellar object ever selected for a formal planetary defense campaign. Now, before anyone panics, let's be absolutely clear about something. The official position stated explicitly by IAWN, NASA, the European Space Agency, and the United Nations Office for Outer Space Affairs is that 3I Atlas poses no threat to Earth. The trajectory calculations show that the comet will come no closer than 170 million miles to our planet, which is almost twice the distance between Earth and the Sun. There's zero danger of impact. Zero. So why activate the Planetary Defense Protocol at all? According to the official explanation from IAWN, 3I Atlas presents a unique opportunity for training because of its prolonged observability from Earth and its high scientific interest. Comets pose special challenges for accurate trajectory measurements because they're not solid points of light like asteroids. They have extended structures, fuzzy comets, and tails that can systematically pull centroid measurements away from the actual nucleus, making precise orbit predictions more difficult. The goal of this campaign, running from November 27 through January 27, 2026, is to exercise the capability of the global observing community to extract accurate astrometry from cometary objects. That's the official explanation. But here's where the story gets considerably more complex. On September 30, 2025, 3 weeks before IAWN announced this campaign, Harvard astrophysicist Avi Loeb submitted a white paper to the United Nations. The paper, co-authored with Omer Eldadi and Gershon Tenenbaum, advocated for coordinating global scientific research to maximize observational coverage of interstellar objects like 3I Atlas. But the reasoning in that white paper was striking. It specifically mentioned that such objects could pose a threat to humanity if they happen to carry alien technology. Loeb argued that black swan events with small probabilities must be considered seriously if their implications for the future of humanity are large. And then, 3 weeks later, IAWN announces their campaign targeting exactly TH. Object Loeb's white paper discussed. Coincidence? Maybe. But the timing is certainly interesting, especially when you look at what Loeb has documented about 3I Atlas's confirmed trajectory and behavior. Let's talk about that trajectory, because the numbers are genuinely extraordinary. When 3I Atlas was first detected on July 1, 2025 by the Atlas telescope in Chile, astronomers immediately recognized it as an interstellar object based on its hyperbolic orbit. Objects from our solar system follow elliptical paths bound by the sun's gravity. Interstellar visitors follow hyperbolic trajectories, meaning they're moving fast enough to escape the sun's gravitational pull entirely. They come in, swing around, and leave, never to return. That part is normal for an interstellar object. What's not normal is the specific trajectory that IAWN has now confirmed through hundreds of observations from observatories worldwide. The orbit of 3I Atlas is aligned to within 5 degrees of the ecliptic plane, which is the flat disk where all the planets orbit the sun. Now think about that for a moment. Space is three-dimensional. An object arriving from interstellar space could come from any direction, any angle. The probability that it would randomly arrive aligned with the planetary plane is about 0.2%. That's 1 in 500. Not impossible, but definitely unusual. But that's just the beginning. The confirmed trajectory shows that 3I Atlas's arrival time was exquisitely fine-tuned to bring it within tens of millions of kilometers of Mars, Venus, and Jupiter, while simultaneously ensuring it would be unobservable from Earth during its closest approach to the Sun. During the entire month of October, while 3I Atlas passed through perihelion on October 29th, it was hidden behind the Sun from our perspective, making ground-based observation impossible. Only spacecraft on the far side of the solar system, like NASA's Mars orbiters and the Punch mission, could see it during this critical period. The statistical probability of an interstellar object randomly arriving with a trajectory that brings it close to multiple planets while being hidden from Earth at perihelion, Loeb calculates it at 0.005%. That's 1 in 20,000. Again, not impossible, but raising eyebrows. And here's where things get even more intriguing. Remember those trajectory refinements that IAWN is now conducting as part of their official campaign? They're critical because 3I Atlas displayed a non-gravitational acceleration near perihelion. That means something pushed it off the purely gravitational path it should have followed. With normal comets, this happens all the time due to outgassing. As ice vaporizes from the surface heated by the sun, the expanding gas creates jets that act like tiny rocket thrusters, slightly altering the comet's trajectory. Scientists measure these non-gravitational accelerations regularly. For 3I Atlas, the measured acceleration was 5 × 10⁻⁷ astronomical units per day squared. That number might sound abstract, but here's what it means in practice. Over the course of about a month near perihelion, this acceleration changed 3I Atlas's trajectory by approximately 0.1 million kilometers. And this is where the confirmed trajectory becomes absolutely fascinating. The course correction from this non-gravitational acceleration adjusted 3I Atlas's path so that when it reaches Jupiter on March 16, 2026, it will arrive at a minimum distance of 53.445 million kilometers from the planet. Why does that specific number matter? Because Jupiter's Hill radius on that exact date, the boundary of Jupiter's gravitational sphere of influence, calculates to 53.502 million kilometers. You're still watching, hit that like button right now, because what I'm about to explain is the reason some scientists privately describe this as the most statistically improbable cosmic coincidence they've ever seen. The Hill radius is the region where a planet's gravity dominates over the sun's gravity. Inside that radius, the planet can hold on to orbiting satellites. The famous Lagrange points, those equilibrium positions where gravitational forces balance out, sit right at the edge of the Hill radius. They're ideal locations for placing spacecraft because they require minimal fuel for station keeping. Now, 3I Atlas is going to arrive at Jupiter at exactly the edge of that gravitational sphere of influence. The difference between its closest approach distance and Jupiter's Hill radius is 0.06 million kilometers. That's a margin of 1 part in 1,000 for the specific distance, but when you consider the full diameter of Jupiter's orbit, it's a coincidence of 1 part in 26,000. And remember, the non-gravitational acceleration that fine-tuned this approach happened while 3I Atlas was hidden behind the sun from Earth's view during the optimal moment for a spacecraft to use the Oberth effect to maximize any trajectory adjustment. Is this why IAWN activated the protocol? To verify these trajectory calculations with the highest possible precision. The campaign that began on November 27th involves a level of coordination rarely seen in astronomy. Observatories across the globe, from professionals to skilled amateurs, registered for a workshop held on November 10th to learn advanced comet astrometry techniques. The workshop covered methods for correctly measuring comet positions despite their extended coma and tail structures, calibrating timing systems using navigation satellites, and submitting data in the standardized ADES format that allows for precise comparison between different observatories. Registration closed on November 7th, and only participants who attended the workshop are allowed to contribute observations to the campaign. This isn't casual skywatching. This is a rigorous scientific exercise designed to extract the most accurate trajectory data possible. The campaign includes specific checkpoints, a mid-campaign review on December 9th, and a close-out teleconference on February 3rd, after the observation window closes on January 27th. Every measurement, every data point, every observation during this 2-month period feeds into refining our understanding of exactly where 3I Atlas is going and exactly how it's moving. But why the urgency? Why activate this protocol now? One reason might be the accumulation of anomalies that Loeb and his colleagues have documented. Beyond the trajectory alignment and the Jupiter-Hill radius coincidence, there are 6 other statistically unusual characteristics. The nucleus of 3I Atlas is estimated to be between 1,400 feet and 3.5 miles in diameter, making it approximately 1,000,000 times more massive than Oumuamua, the first interstellar object, and about 1,000 times more massive than Borisov, the second interstellar visitor. Yet it's moving faster than both of them. The combined probability of having this much mass while moving this fast from an interstellar origin, less than 0.1%. The gas composition is bizarre. Spectroscopic observations detected nickel in the Comet at levels much higher than iron, which is the opposite of what we see in natural comets. Natural space materials have iron to nickel ratios reflecting stellar nucleosynthesis, but industrially produced nickel alloys flip that ratio. The nickel to cyanide ratio in 3I Atlas is orders of magnitude larger than any known comet, including Borisov. Probability, less than 1%. Then there's the water content. Normal comets are basically dirty snowballs, with water ice as the primary constituent. 3I Atlas shows only 4% water by mass, detected by NASA's MAVEN orbiter and the Swift telescope. For context, Halley's Comet is about 80% water ice. Where did all the water go, and what is the other 96% of this object made of? The polarization measurements are off the charts. When sunlight reflects off cometary dust, it becomes polarized in predictable ways that tell us about the particle sizes and compositions. 3I Atlas showed extreme negative polarization, a signature unprecedented for all known comets including Borisov. Statistical likelihood compared to the known population, below 1%, and there's the jet structure. Post-perihelion images from early November show at least 7 distinct jets emanating from the nucleus, with several being antitails pointing toward the sun rather than away from it. For a rotating comet, jets should create visible wobbles or wiggles in the tail structure as the nucleus spins. 3I Atlas rotates every 16 hours, but its jets remain remarkably steady, as if they're not tied to surface ice patches being heated by sunlight, but rather to something else controlling their direction. When you multiply all these individual probabilities together, the alignment with the ecliptic plane, the fine-tuned arrival near multiple planets while hidden from Earth, the Jupiter-Hill radius precision, the extreme mass while moving fast, the unusual nickel-rich composition, the lack of water, the unprecedented polarization, and the steady jet structure, you get a cumulative probability of less than 1 in 10 quadrillion. That's a 1 followed by 16 zeros. To put that in perspective, your odds of winning the Powerball jackpot are about 1 in 300 million. You'd have to win the Powerball jackpot, then win it again, and then win it a third time, and your cumulative odds would still be 10,000 times more likely than this collection of 3I Atlas anomalies occurring by chance. This is why Loeb has placed 3I Atlas at a 4 out of 10 on his scale of possible technological origin. Not definitive proof, not wild speculation. Just a measured assessment that the probability space for natural explanations is getting uncomfortably small. So what exactly is IAWN looking for during this campaign? The official goal is to refine astrometry techniques and test coordination protocols. That's true and important, but there's a deeper layer. If 3I Atlas were to display any trajectory deviations beyond what can be explained by natural outgassing, if there were any course corrections visible in the refined orbital data, if the object releases anything during its observable period, IAWN's network of observatories would detect it. The Minor Planet Center, which coordinates asteroid and comet observations worldwide, issued a formal notice designating this as a comet campaign to improve trajectory predictions for extended fuzzy objects. But that notice also acknowledged that cometary bodies present challenges because their morphological features can systematically affect measurements. In other words, if something unusual is happening with 3I Atlas, distinguishing it from normal cometary behavior requires extraordinarily precise data. That's what this campaign is designed to provide. The timing is also significant. The observation window runs through January 27th, which takes us well past December 19th, when 3I Atlas makes its closest approach to Earth at 170 million miles. That's our best opportunity for detailed observation from ground-based telescopes. Then the campaign continues through late January, allowing observers to track any changes in behavior as the comet moves outward toward its March 16th encounter with Jupiter. If Loeb's calculations about the Hill radius approach are correct, and if there's any technological component to this object, the period between now and mid-March is when we'd see evidence. A mothership approaching Jupiter's gravitational sphere might deploy smaller probes. It might perform a course correction. It might do nothing at all, simply passing through on a trajectory determined billions of years ago when it was launched from a distant star system. But we won't know unless we watch with every available instrument. And that brings us to the conspiracy theories that have exploded across social media in the past month. When news of the IAWN campaign first leaked in late October, before the official announcement, speculation ran rampant. Some claimed this was proof NASA knows 3I Atlas is artificial and is secretly preparing for first contact. Others suggested the Planetary Defense Protocol activation means there's a hidden danger NASA isn't revealing. The 43-day government shutdown that prevented NASA from commenting publicly for most of October fed these theories. By the time NASA held their press conference on November 19th, sharing images from over 20 spacecraft, the internet was primed for drama. NASA's response was unequivocal. Associate Administrator Amit Kshatriya stated clearly, 3I Atlas is a comet, it looks and behaves like a comet and all evidence points to it being a comet. Nikki Fox emphasized that no techno-signatures have been detected. ESA officials gave similar statements. The message from official channels is consistent. Natural comet, scientifically interesting, no threat, no aliens. But here's the thing about that official position. It doesn't actually contradict what Loeb and others are saying. Loeb isn't claiming 3I Atlas is definitely artificial. He's saying the anomalies warrant investigation with an open mind. NASA isn't saying the anomalies don't exist. They're saying their interpretation is that natural explanations fit the data. Both positions can be simultaneously true depending on how you weigh the probabilities. The fundamental question is philosophical as much as scientific. When you encounter a series of individually unlikely characteristics that compound into extreme statistical improbability, at what point do you seriously consider alternative hypotheses? The scientific method says you should always consider the simplest explanation first. Natural comets exist. We've observed thousands of them. We understand how they work. 3I Atlas has cometary features, a coma, a tail, outgassing, a nucleus. Therefore, the null hypothesis is that it's a natural comet with some unusual but ultimately explainable properties. That's the conservative, rational position. The alternative hypothesis, that 3I Atlas might incorporate technological elements, requires extraordinary evidence because it's an extraordinary claim. We've never confirmed alien technology anywhere in the universe. We don't know if such technology exists, how it would work, or what it would look like. Proposing that an observed object is artificial requires meeting a much higher burden of proof than accepting it's natural. This is where the IAWN protocol activation becomes so important. The campaign isn't assuming either hypothesis. It's gathering the best possible data so that whatever conclusions we reach, they're based on precise measurements rather than speculation. If the refined trajectory shows no deviations beyond standard cometary behavior, if the composition can be explained by formation in an unusual stellar environment, if the jets follow patterns consistent with rotating surface features, then the natural explanation strengthens. If anomalies persist or deepen, if unexplained behaviors emerge, then alternative hypotheses gain credibility. We're now entering the most critical observation period. Right now, as of November 29th, 3I Atlas is in the constellation Virgo, visible through medium-sized telescopes at apparent magnitude 10. Amateur astronomers with dark skies and decent equipment can photograph it, contributing to the global dataset. Professional observatories are conducting spectroscopy, measuring precise positions, tracking brightness variations, and monitoring for any changes in the jet structure or coma morphology. In 3 weeks on December 19th, we reach closest approach. That's when every major telescope not blocked by weather will be pointed at this object. We'll get the highest resolution images, the most detailed spectra, the most precise astrometry. And then we watch what happens as it moves outward. Does the trajectory hold to predictions? Do the jets continue operating, and if so, powered by what mechanism given the low water content? Does the rotation rate change as we'd expect if mass is being lost to outgassing? Every measurement answers questions and raises new ones. The March 16th Jupiter encounter is the ultimate test. NASA's Juno spacecraft, currently orbiting Jupiter, will have a direct view of 3I Atlas as it passes through the outer solar system. If anything unusual occurs, if there are course corrections, if objects separate from the main body, if there's any activity that can't be explained by natural processes, Juno will detect it. And if nothing unusual happens, if 3I Atlas simply coasts past Jupiter following Newtonian mechanics with no surprises, that's important data too. It would suggest that the Hill radius coincidence really is just a coincidence, that the trajectory alignment happened by chance, and that the other anomalies, while unusual, fall within the range of natural variation for comets formed around different types of stars. Either outcome teaches us something profound about our universe. What makes this moment so historically significant is that we're finally in a position to properly study an interstellar visitor. Oumuamua came and went before we could react. It was discovered on its way out of the solar system, already past perihelion, moving fast and fading quickly. We got a handful of observations before it disappeared into the dark. Borisov gave us more time, detected on its way in, observed through perihelion and beyond, but it never came particularly close to Earth and remained fairly typical in its behavior. 3I Atlas is different. It's large enough to study in detail. It's bright enough to observe with a wide range of instruments. Its trajectory brings it relatively close to Earth for an interstellar object. And now, for the first time, we have a coordinated global campaign specifically designed to extract every possible piece of information from its passage. The IAWN protocol activation ensures that observations are standardized, data is shared, and analysis is coordinated across international boundaries. This is what planetary defense infrastructure looks like in practice. It's not dramatic. There are no explosions, no heroic last-minute saves, no Bruce Willis moments. It's astronomers carefully measuring positions, comparing notes, checking calibrations, and building up a comprehensive picture over weeks and months. It's workshops on measurement techniques. It's standardized data formats. It's teleconferences to review progress. It's the unglamorous work of science done rigorously and collaboratively. But the implications are profound. We're testing our ability to track objects from interstellar space. We're verifying that our detection networks, communication protocols, and analysis pipelines work when faced with a genuine unknown. If someday an actual threat emerges, a near-Earth object on a collision course, the lessons learned from this 3I Atlas campaign will inform our response. We'll know how to coordinate quickly, we'll know which techniques work for extracting accurate trajectories, we'll know how to distinguish real anomalies from measurement artifacts. We'll be prepared. Make sure you're subscribed with notifications turned on, because the next 2 months are going to be critical, and updates will come regularly as new data arrives. The observation window runs through January 27th, with the mid-campaign check-in happening on December 9th. We'll know by then if the trajectory refinements reveal anything unexpected. The closeout teleconference on February 3rd will synthesize all the observations and preliminary conclusions. And then we watch what happens at Jupiter in mid-March. Drop a comment below with your thoughts. Do you think the IAWN protocol activation is simply a training exercise using a conveniently available target, as the official explanation states? Or do you think the accumulation of statistical anomalies Loeb has documented suggests there might be more to this story than standard scientific caution allows us to say publicly? This is the beauty of science in action. We don't have to guess. We don't have to speculate endlessly. We can observe, measure, analyze, and let the data guide our understanding. What we're witnessing right now is humanity taking its first serious steps toward becoming a species capable of monitoring our cosmic neighborhood. The International Asteroid Warning Network, the Space Mission Planning Advisory Group, the United Nations Office for Outer Space Affairs, these aren't just bureaucratic organizations. They're the infrastructure of planetary defense, the early warning system that might someday save civilization from an extinction-level impact. The fact that they're activated right now, coordinating observations of 3I Atlas, shows that the system works. Whether this particular object turns out to be a natural comet with fascinating but explainable quirks, or whether it represents something more exotic, the process we're going through to find out is exactly what we should be doing. We're watching, we're measuring, we're analyzing, and we're preparing for whatever comes next. Share this with anyone who wants to understand what's really happening with 3I Atlas and why the trajectory confirmation matters. These are the moments that define our relationship with the cosmos, where human curiosity and scientific rigor combine to explore the greatest mysteries. The confirmed trajectory of 3I Atlas takes it past Jupiter and out of our solar system forever, a visitor from another star that passed through our neighborhood for just a few months. But the data we gather, the techniques we refine, the coordination we achieve during this campaign will serve humanity for decades to come. Until next time, keep looking up, keep questioning, and keep following the evidence wherever it leads.